On June 30th, 1908, something catastrophic happened over a remote forest in Siberia. An explosion so powerful it flattened 80 million trees across an area the size of a city. Yet no crater was ever found. No meteorite recovered. For over a century, scientists have debated what actually happened that day and whether we're looking at one of Earth's greatest unsolved mysteries, or evidence of something far more extraordinary. Today, we're diving deep into the Tunguska event, a case that still has researchers questioning everything we think we know about what fell from the sky. The morning everything changed. On the morning of June 30th, 1908, the indigenous Evenki people in central Siberia witnessed something they'd never forget. A brilliant fireball streaked across the sky, brighter than the sun itself. Then came a blast so violent it knocked herds of reindeer, thousands of them dead where they stood from miles away. Eyewitness accounts describe a shock wave that flattened forests in a radial pattern for over 80 kilometers. The explosion released energy equivalent to 10 to 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Yet the remote location meant no scientific investigation happened for nearly 2 decades. The first expedition, what they found and didn't. It wasn't until 1927 that Russian scientist Leonid Kulik led the first serious expedition to the site. What he discovered was shocking: an area of roughly 2,150 square kilometers completely devastated. Trees lay radially outward from a central point like matchsticks. But here's what made scientists scratch their heads: there was no impact crater, no meteorite fragments, no obvious evidence of what caused the explosion. Kulik believed a metallic meteorite had vaporized on impact, but the total absence of debris was puzzling. Later expeditions in the 1960s found some microscopic metallic spheres in the soil, suggesting an extraterrestrial origin, but the evidence remained frustratingly inconclusive. The leading theory: a comet explodes in the atmosphere. Most scientists today support what's called the cosmic airburst hypothesis. Rather than hitting the ground, the evidence suggests a comet or asteroid around 60 meters wide entered Earth's atmosphere and exploded before impact, a process called an airburst. The force of the detonation, occurring roughly 5 to 10 kilometers above the surface, was enough to flatten forests without ever touching down. This would explain the lack of a crater and the absence of substantial meteorite fragments. Similar airbursts are theoretically possible. In 2013, the Chelyabinsk meteor exploded above Russia in the atmosphere, and in 1490, a similar event may have occurred over China, both leaving little ground evidence. The alien hypothesis: why some scientists won't rule it out. Here's where things get interesting and where the alien angle comes in. A minority of researchers, including some legitimate scientists, have proposed that Tunguska could represent evidence of an extraterrestrial craft or weapon. The arguments: the precision of the explosion, the lack of impact debris, the sudden nature of the event. Some have even suggested it could have been an alien spacecraft that malfunctioned or was shot down. While this remains firmly in fringe science territory, it's worth noting that the sheer strangeness of Tunguska has made it impossible to completely dismiss unconventional theories. The absence of evidence became, for some, evidence of concealment. What we've learned from modern research. In recent decades, computer simulations and studies of similar airbursts have provided compelling evidence for the cosmic airburst model. In 2008, exactly 100 years after Tunguska, scientists published detailed research showing that a 60-meter stony asteroid exploding at altitude could produce precisely the damage pattern we see. The 2013 Chelyabinsk meteor, which exploded above Russia and injured over 1,000 people, validated these models in real time. Yet new questions emerge. How often do such events occur? Could a larger object cause a civilization-ending catastrophe? And are we adequately prepared to detect and respond to similar threats? Why Tunguska still matters today. The Tunguska event isn't just a historical curiosity, it's a stark reminder of planetary vulnerability. The explosion occurred over uninhabited wilderness. If a similar event happened over a major city, millions could perish. It's driven substantial funding into asteroid detection and planetary defense programs. NASA, ESA, and other space agencies now monitor near-Earth objects with unprecedented vigilance. Missions like DART, the Double Asteroid Redirection Test, are actively testing our ability to deflect incoming threats. Tunguska demonstrated that Earth is not immune to catastrophic impacts, and that complacency could be deadly. In a very real sense, understanding what happened in 1908 Siberia may be critical to humanity's survival. The Tunguska event remains one of science's most captivating unsolved mysteries. Was it a comet? An asteroid? Something else entirely? The evidence points toward a cosmic airburst, but the total absence of recovered material ensures debate will continue. What's undeniable is that Tunguska changed how we view our planet's place in a dangerous universe. If you enjoyed this video, smash the like button and subscribe so you never miss a video like this one.